You're welcome to Excellent Simplified Tutorials.
So today we'll be looking at one aspect of calculus, and we'll be looking at differentiation. Now, in calculus we'll be looking at differentiation and integration, but for today we'll be looking specifically at differentiation using the formula method. Now, there are different methods in solving differentiation questions, but one of the methods is formula method. We'll start from there and we progress to other methods, but for today we'll be starting from the formula method. Now, one thing you need to know is calculus is very simple. Forget about maybe the lies you were told that calculus is difficult. No, calculus is the simplest aspect of mathematics. Good. Now, using the formula method, for any function given as y equal to ax raised to power n, any function you are given at all, let's say y equal to ax raised to power n, where a and n are constants, dy over dx is equal to n times ax raised to power n minus 1. What does that mean? Before we analyze that formula, there are two things you need to know. When we talk about constants, constants are values, numbers. 1 is a constant, 3 is a constant, 10 is a constant. When we talk about variable, variable is not a constant. Variable can have any value. For example, x is a variable because x can represent 1, x can represent 2, x can represent anything. So x is a variable. But when we talk about 15 is 15 a variable or a constant? Is 15 a variable or a constant? A constant, right? Good. Now, if you are given any value to differentiate, we can go with this. This is the formula we use. First, if you are asked to differentiate, you always start with dy over dx. dy over dx equal to, this means you are differentiating y with respect to x. Do we get? Dy dx means you are differentiating y with respect to x. If you write something like this, dx over dt, what it means is you are differentiating what? X with respect to what? T. If you are giving dt over dz, it means you are differentiating t with respect to what? Z. Do you get that? Now, if we are given this to differentiate ax raised to power n, all you need to do, this power here, bring it to the side, use it to multiply the side. That is why we brought n, which is the power here, times a was already here, right? This is our value, x. This is our variable x here. Then our n, anything you have up here, you subtract 1 from it. This is what I mean. If you are asked to differentiate you are asked to differentiate 2x raised to power 3, what will you do? First, dy dx is equal to, now differentiating this, what do we do? The first thing is what? Bring the power to the side, right? That is 3 times 2 x raised to power, anything you have here, you subtract 1 from it. So what you have now is 3 times 2 is what? 6. X raised to power 3 minus 1 is what? That's all. Anytime you are differentiating, just use the power to multiply the coefficient, then subtract 1 from the power. That is what we have. That's the formula method. There are other ways you can solve this. You can use the first principle to solve, but we're starting with this. Any question on that before we start example solving it? Okay, let's solve this together. Example 1, differentiate the following with respect to their variables. Let me start with the first one. We are asked to differentiate y equal to x squared. Now remember, if you are differentiating dy over dx, that is, we are differentiating y with respect to x, will give us, the first thing you do is to do what? The power, bring it to the side, right? Is it not? So we'll be having 2 times, nothing is here. Now x raised to power what? 2 minus 1. You subtract 1 from anything you have as the power. So we are left with 2x raised to power what? 2 minus 1 is 1, right? So 2x raised to power 1, right? Which is same thing as saying 2x, right? Is it not? That's the answer. Is it not simple? The second one now, we are asked to differentiate y equal to 3x raised to power 5. So if you are differentiating this, still the same approach. Dy over dx is equal to, what do? We bring the power here, right? So we'll be having 5 times what? Times 3 x raised to power 5 minus 1. So dy dx will give us 5 times 3 will give us what? 15 x raised to power what? 4. That's it. So write this down and solve number 3 for me. That's number 3. Let's solve it together. We have to differentiate y equal to 14x squared. Now the y dx will give us what? Let's just jump principles now. 2 times 14 will give us what? 28, right? X raised to power 2 minus 1 will give us what? 1, right? Which is 28x, is it not? Good. Number 4, we're asked to differentiate y equal to minus 12x raised to power 6. Now dy dx, dy over dx, differentiating y with respect to x, 6 times minus 12 will give us what? Minus 72, right? X raised to power what? 5. Remember to subtract 1 from your power. The next one, number 5, s equal to 3t raised to power 4. Now what are we differentiating here with respect to what? We are differentiating s with respect to t, right? So if you are writing it, you will write something like ds over dt. Do you get? Let's differentiate s with respect to t as the equation goes. Now here, this will be 4 times what? 3t raised to power what? 3, right? So this will give me what? 12t raised to power 3. Good. So number 6, y equal to x. What is your answer here? 1, right? Because now if you are differentiating this, the y over the x is equal to, x is the same thing as x raised to power 1, is it not? Bring 1 to the side here and minus 1 from what was there, is it not? So we'll end up with 1x, 1 minus 1 is what? 0, right? Anything raised to the power of 0 is what? 1. 1. That's our answer there. Any question on this? Before we advance a little. No question. Write it down. Alright, so let's solve this together. The question says, example 2, differentiate the following with respect to their variables. Let's start with the first one. Y, number 1, y equal to 1 over x raised to power 2. Now, from our knowledge of indices, please look up. The y over the x is equal to, 1 over x raised to the power minus 2, x raised to the power 2 is the same thing as saying x raised to the power what? Minus 2, right? Raised to the power minus 2. This is the same thing as this, is it not? So if you want to differentiate this now, what do? Bring the power to the side, is it not? So we'll be having minus 2x raised to the power minus 2 minus 1. Remember, we're always subtracting 1 from the power, right? So at this point here, we'll be having minus 2x raised to the power minus 2 minus 1 is what? Minus 3. Good. You can leave your answer like this, or you can decide to say this is also equal to minus 2. This x raised to the power minus 3 is same thing as saying 1 over x raised to the power 3, right? Is it not? So I can decide to put it in this format. I can decide to say this is 1. Did I change anything? Did I change anything? Do you understand this? Good. So what I did here was, this is the same thing as saying minus 2 times x raised to the power minus 3, right? This will stop here. Now I can say minus 2 times, this is the same thing as 1 over x raised to the power 3. Is it not? If this multiplies, minus 2 times 1 will give me minus 2 over x raised to the power 3. So this is your answer to that question. Let's solve number 2 together. We have to differentiate. This is equation number 2. T equal to 3 over s raised to the power 6, right? Good. Now if we are to differentiate this, are we together? This stuff here, 3 over s raised to the power 6 is same thing as saying 3 times 1 over s raised to the power 6. Is it not? Is it not? Have I changed anything? 3 times 1 will still give me 3 over this. Is it not? So this is same thing as saying this is equal to 3 times s raised to the power what? Minus 6. Is it not? And so this is equal to 3 s raised to the power minus 6. We've not differentiated though. I just changed the format to show you that this is the same thing as this, according to the laws of indices. Now if we are to differentiate the y, we are differentiating with respect to s, right? We are differentiating t with respect to s. So the t over the s is equal to, if we are differentiating this now, the t over the x of 3x raised to the power minus 6 will be equal to what? I bring this power here, right? So I'll be having minus 6 times what? 3. Then s raised to the power minus 6 what? Minus 1. Good. So I'll be having minus 6 times 3 is what? Minus 18. S raised to the power minus 6 minus 1 is what? Minus 7, right? Good. You can leave your answer like this, or you can change it to minus 18 over s raised to the power what? X raised to the power 7. Because this is same as this according to the laws of indices. Do you understand this? Do you understand this? Let's solve number 3 together. The question says if y is equal to 10, find the y dx. Now y equal to 10. We have to differentiate this. If you have to differentiate this, remember that 10, this is same thing as saying 10 equal to y equal to 10x raised to the power 0, right? 10 is the same thing as 10x raised to the power 0 because x raised to the power 0 is still 1. 1 times 10 is still 10. So 10 is the same thing as 10x raised to the power 0. You've not changed anything. Now if you are differentiating this, the y, the x of this will give us 0 times 10, right? 0 times 10 and x raised to power what? 0 minus 1. So you'll be having 0 times everything here is what? 0. So anytime you are differentiating a constant, your answer is 0. If you ask to differentiate 1 million, 0. If you ask to, in OBJ exams, you don't need to even solve this. Once you see it's a constant, 0. Take your answer and go. Do we get? Good. Now, number 4. We are asked to differentiate y equal to 13x with, they said, now look at this. If y, you have to pay good attention to this question. If y equal to 13x, find dy the what? Dy dt. That is, you are differentiating y with respect to what? T. Is it not? Good. So what's the answer to this question? Dy over dt is equal to 0. If they've said dy dx, differentiate y with respect to x, then you can solve because x is here. But this one, dy dt, they say differentiate y with respect to t. But with respect to t, this is a constant because there's no t here. Do you get? So it's just like saying this t raised to power 0. This is it. Then 0 times everything here because this is a constant so long as t is concerned. So 0 times this will give us what? 0. So please always pay attention to what you are differentiating with respect to. Because I know once you see this question, wow, this one is very simple. Now you just differentiate. No. With respect to what? You are differentiating with respect to what? Do you know why this is 0? Because I'm sure in the option you will see, normally if you are differentiating this with respect to x, what will be your answer? 13, right? With respect to x, this will give you 13. In the option you see 13, well, this one was very simple. You take 13 and move. No. So always check what you are differentiating with respect to. Any question before we advance one step again? Alright, so in this case, example 3, if y equal to root x, find dy over dx. Please go and watch my video on indices because that's what we are applying here. That indices class, I told you, will be applying indices in all the topics in mathematics. Now, y equal to root x. You know from indices, this is the same thing as root x is the same thing as x raised to power what? Half, right? So if we are differentiating this, dy over dx will be equal to, remember what you said, this will come here, right? This will come here. So if this comes here, we'll have what? Have what? X raised to power 1 half minus what? 1. Remember, this power will come here, then you subtract 1 from anything you have here. Do we get that? Yes. Now, if we continue, this will give us half x raised to power half minus 1 is what? Minus half. Good. Minus half. This can be your option. This can be your option. But you can still simplify this. You know, this is same thing as saying, if you want to remove this minus here, what do? This half times, if I want to remove this one minus, I said 1 over x raised to power what? Half, right? Right? Just removing the minus, I'll have to do this, right? 1 over, is it not? Now let's bring the two fractions together. 1 times 1 will give me what? 1 over 2 times the whole of this will give me what? 2x raised to power what? Half. Here's your answer. Can this also be written as 1 over 2 root x? Is this and this the same thing? Yeah. The same thing. So depending on how your option is, remember x raised to power 1 over 2 is the same thing as root x here, right? So this is same as this. So anyhow you see it in your option. Alright, let's work together. Find the derivative of this. That is why I said please go and watch that video on indices, because we are still applying it here. Now, find the derivative of 1 over x root x, right? From our laws of indices, you agree with me that this is same thing as saying 1 over x times root x is the same thing as what? X raised to power what? Half, right? So x raised to power 1 over 2. Good. Now this is same thing as saying 1 over, now from the laws of indices, I'm having the same base here. X is the same thing as what? X raised to power 1, right? Good. So this is the same thing as x raised to power 1 times x raised to power half. Now, when the bases are the same and you have multiplication there, what do you do to the powers? You add, right? So this is same as saying x raised to power what? 1 plus 1 over 2. Is it not? Now, 1 over x raised to power 1 plus 1 over 2 is what? 1 plus 1 over 2 is what? This is not 1 and half. What's the LCM? 2, right? 2 divided by 1. 2 divided by 1. 2 times. You hope you know how to combine these stuff together. So here will be what? 2, right? Plus 2 divided by 2. 1 times 1. So what are you having? 2 plus 1 is what? 3 over 2. So 1 plus half is 3 over 2. So we are having x raised to power what? 3 over 2, right? Good. Now at this point, you know this is same thing as writing it this way. If I want to remove this 1, what do I do? This will be what? X raised to power what? Thank you very much. Minus 3 over 2. We've not even started differentiating now. Alright, so at this point, we can now differentiate. If you are asked to differentiate now the y dx, now will give us the y over the x. If I'm differentiating this, what do I bring to the side? Minus 3 over 2. X raised to power minus 3 over 2 minus what? Minus 1. Good. So I'll be having now, this is minus 3 over 2 x raised to power. Now, minus 3 over 2 minus 1 will give me what? Plus 5 over 3, right? Plus 5 over 2. How do you get that? The LCM is 2, right? 2 divided by 2 is what? 2 divided by 2 is what? 1, right? 1 times 3 is what? Minus what? Minus 3 here. Now minus 2 divided by 1. 2 times 1. So I'll be having minus 3 minus 2 will give me what? Minus 3 minus 2. Minus 5 over 2, right? So everything here will give me what? Minus 5 over 2. Is it not? Do we have something like that in the option? Now, if you look at this, this is the same thing as say, if I want to remove this, if I want to change this, you know it's the same thing as saying minus 3 over 2 times x raised to power minus 5 over 2, right? This is the same thing as this. If I want to remove this minus, what do I do? This same thing as saying minus 3 over 2 times 1 over x raised to power what? 5 over 2. Good. Now if I multiply this out, what do I have? Minus what? Minus 3, because minus 3 times 1 is minus 3, all over 2x raised to power what? 5 over 2. Option what? A is the answer. Let's solve this together. Hello, are we together? Now the question says, if y is equal to x raised to power minus 3 over 2, then dy over dx is what? Now if we are asked to solve this, dy dx, meaning we are differentiating y with respect to what? X, right? So dy dx will give me, now anything you have here, what do? You bring to the side, right? So I'll be having minus 3 over 2 x raised to power what? Minus 3 over 2 minus what? 1. Good. Now, and you agree with me that minus 3 over 2 minus 1, the LCM here is what? 2, right? So 2 divided by 2 give me what? 1 times minus 3 minus 3. Now 2 divided by 1 here, 2 times 1, so I'll be having minus 2, right? So minus 2 minus 3 minus 2 is what? So minus 5 over 2. Now the y over the x will give me minus 3 over 2 x raised to power what? Everything here we've gotten it as what? Minus 5 over what? 2. Now this is our answer, and that is option what? Option D. Is it not simple? So write that down. Let's advance a little. Let's solve this together. Now we are asked to find the derivative of 4x raised to power 3 minus 12x raised to power 2 plus 3x plus 12. Now what you apply here is differentiation by parts. The y, the x, differentiating y with respect to x here. First you differentiate them individually, like you differentiate this one, you differentiate this one, you differentiate this one, you differentiate this one. Now if we are differentiating 4x raised to power 3, what do we do? 3 times what? We've done this before, so let's omit some steps now. 3 times what? 4, right? Which will give us what? 12x raised to power, anything you have here is minus 1, right? Raised to power what? 2. You are done with this one. Minus 2 times 12 will give me what? So 24 x raised to power 2 minus 1 is what? 1, right? So 24x plus differentiating 3x, what do you have? 3, right? Plus differentiating 12 is what? 0. Remember, differentiating a constant, you have 0. So this is the answer to this question. Okay, so let's solve this together. If you are asked to find the second derivative means differentiate 2 times. Now, like in this question, they did not say derive 2 times or find the second derivative. Second derivative is represented by this squared y all over the x squared. Anytime you see something like this, know what they're asking you is to find the second derivative. Is it not? Is it not? If you are asked to find something like this, this is asking you to find the first derivative. If you are giving something like this, you are asked to find the second derivative. So take note of all these notations. And now if you are to find the second derivative, simply differentiate 2 times. So first, we differentiate this the first time. So the first derivative will give us what? If we differentiate this the first time, what do we have? 3 times 3 will give us what? 9x raised to power what? 2, right? Because 3 minus 1 will give me 2. Minus 2 times 2 will give me what? 4x, right? Plus differentiating 4 will give me what? 0. Good. This is the first derivative. We'll differentiate the second time. Remember, they say find the squared y, meaning find the second derivative, is it not? So the second derivative now will give me 9 times 2 is what? 2 times 9 is what? 18, right? 18 what? X, because 2 minus 1 is 1. Minus differentiating this will give me what? Will give me what? 18x minus 4. That's our answer. Do you understand that? So it's basically you are repeating the same step 2 times. That's the answer.